me do anything for the rest of the day. Because I started early.
I think you still got more time than I did.
But he not deserve it, so.
That's right.
What?
Anything?
No, I didn't open my laptop. Also because I didn't have internet.
I told myself I'm gonna get so much done. I'm gonna be super productive.
My internet went
comes and I'm like,
No, I don't know the settings. My internet sucks to the point where like
come with them too. I'm gonna be happy. But I only need 2 hours.
So the thing with productive work is like an oxymoron.
Yeah, so at that point,
I mean,
I was also cooking, I
about to
was
get
seeing
quick.
friends, and I had so much going on that I was not already working on my plan. Get it done in the next 2 weeks or my ass. So.
I took a look at that project. It wasn't too bad, especially because
The project?
yeah.
FAK.
No, because in class we worked on the same problem.
The open desk?
Yeah.
No, we didn't.
I don't
No.
know. I could have sworn we did.
No, this morning we did.
No, not this morning, but like a while ago. This was like
No, you're thinking of like the gears.
My
the
class.
gears.
No, I'm thinking of the hoop and the disc, like the marble inside. I could have sworn we did something like that.
My class definitely did.
We did?
Did
We did not.
I could have.
I don't remember doing it.
I'll have to ask Dominic. I could have sworn we did something like that.
The hazard change.
And MVP for our project, Peter's room.
Pretty much.
MVP for both of the big 40-point projects. Peter's roommate and Peter's roommate.
And Dominic were coding everything like a chat. Dominic actually actively improved the code. Because he took what was Panoski's code and just straight up made it better. I'm like, okay. Like for the line tracing function, he just Panoski was previously tired of like being bullshit. And I'm like, hey, Dominic, try this. And like, what? It's just a thing from MATLAB documentation. He plugged it in at the end and it works. And I was like, all right.
I remember for the line tracing, he has like 10 or 15 lines of code.
Yeah, this one worked in 6.
I was going to say, mine was like in 4 and found it the same thing in like 2.
It wasn't the forums, it was the official documentation for it.
This one was on Apple's forum.
It
probably is.
But it wasn't like someone asked a question and someone gave their best attempt at it.
Yeah, no, it was like
this is
how
the
to
MATLAB developers be like, here is the answer, here you go.
Yeah.
Be free, my child. And I'm like, I will.
Yeah, I did something like
Yeah.
this too. It was like 2. I think mine was like 2 or 3 lines. Of code.
Something
It was
like
really
this.
short.
It's like that much. And
Yeah.
I want to get through on it, but I have that working assignment to be done anyway. And quiz 7, I just remembered that. So.
yeah.
I'll probably start on it tomorrow.
Well, problems 1 and 2, like if you did the, if you looked at the, have you started the structure of the project?
Yeah.
1 and 2,
Yeah.
pretty easy.
If you
Okay, everyone, let's take the press attendance.
then yes.
Thank you.
If you continuously keep screwing up, it's a lot.
The trick I found was to look up the instructions for that large test.
I appreciate it.
Yeah.
Yeah, okay.
They're both custom.
Thank you.
Because they're both custom. You just follow the steps as different.
Yep. No, my, for displacements, it's not in my column, until like 5 decimal places in the displacement. He gives us the link. Yeah, we thought that.
Oh, no. I actually asked him that, just because, like, if you had to make the weight, this project would take you all semester, and I'd give you 5, like, 5.
Okay, so let's
And writing your report.
take a look at updates. Yeah, you know, in my mind, semester is over. Sorry.
I'm cool with that.
Okay, can we
I
back on then?
have to lecture a few, and then the rest you have to do stuff. So basically, here's what here's the checklist. Of course. Today, I don't even know what's today. Today is what, Monday.
Unfortunately.
Yeah.
Monday, still November.
Yeah.
Okay, yeah. So we are probably here. Okay. So now your countdown starts. So Wednesday, we're doing a homework for quiz 7. By the way, quiz 7. Quiz 7. It's almost like a gift. So
Thank you. Early Christmas?
Yeah, it's a gift, right? Quiz 7. If you don't know how to do quiz 7, you're not paying attention. I mean, solutions given, sort of. Okay, so quiz 7, please make sure you pick up 20 out of 20. Okay. Friday, project 2B. How you doing, project 2B? Hope you're done. Good. And then hopefully you're forming a team for project 3. Let's take a look. I have to double check you're forming project group. Okay. I'm going to log in and early.
Nothing if you do that. If you do well, it crashes.
Okay.
Yeah, exactly. So that is the future assignments that you do for 1 hour. Yeah, exactly.
Good point.
Technically, chemistry is like at 100%. It's great, but it also strengthens a portion of your I remember I was doing some calculations, and this is like a rough estimate. I'm not entirely sure how accurate this is, but for my class,
Okay,
I think
fine.
73 out of my something.
My chemistry is, well,
I don't have signal. I don't know why. Sorry, I can't log in, but I hope you're making up your team. I don't even check it. I have no signal. I cannot call anybody. Okay.
In my section, because it was COVID.
So please form up your team for project 3, okay? And then project 3A is basically, it's just a research of what is kind of method and how to use the software kind of thing. It's a very simple thing. Project 3A. This is due Monday, very simple. Just turning in your summary of the report. Okay? You can do very goofy job and screw up 3B, or you can do a very good job of making project 3B very meaningful. Either way, fine. Homework C1, of course, C1 is done. Okay, so you take a look at C1 supplemental video. And this is next week, Monday. C2, C3, we're going to finish up. And the last day of the semester, I think I'm going to call up a special project team and present probably half a class what you're doing on extra class. Yeah, okay. That's what I'm thinking. And this is actually Friday study day.
Study day,
Yeah, study day. This is only day midnight. This is maximum stretch because next day, semester, officially not the semester anymore. Semester ends midnight of study day. It is actually unlawful to do something after that day. So some professors try to shove in some lectures after this day. That's actually not. Okay. You can complain officially to the president. Hey, this professor is trying to do lecture after this day. You cannot do that. I try not to. And then at the same time, after midnight, I'm going to close out Canvas Gradebook, so you cannot access. Okay. So if you want to double check your course grade, please do it before this day, midnight. After midnight, I'm going to close out Canvas Gradebook. You cannot access anymore. Go ahead. Question.
Last day of class being when the special presenters are presenting is the 8th of December on next Wednesday, correct?
Yeah.
Okay.
That's right.
Can I ask why you close out the gradebook?
I just do it every semester. It's my choice.
Fair enough.
Read them of choice. Go ahead.
Fair enough.
After that day, we won't have any access to like your website.
Like I said, well, you can access the website. You cannot look at your gradebook. Grade is lock set. In other words, I'm not going to take any more complaint about your grading. So if you have a complaint or anything, please do it before midnight on study day. I'll be happy to, of course, take a look at if you disagree about my partial credit and stuff. I'll take a look at it, of course. But after that day, that's it. Grade is lock set.
Okay.
I'm not going to change it. Okay.
Oh, for like appeals and stuff.
Yeah, well, why did you give me an 8,
Right.
not a 9 kind of complaint?
Got it.
you can do that, of course. But after that day, I'm not going to do it. Okay. Any question here? So this is just a checklist. And this is final exam. This is section 3. So Monday, December 13, 12:30, not 1 p.m. Be careful. Okay. Okay. Check your calendar.
Yeah.
Okay. Any question about this? This is 2 hours, crossbook notes, 7 programs, comprehensive. Those are the units covered. It's not difficult. Essentially, I'm goofy, so all of those problems are cut and paste problem. Most likely. Go ahead.
That date's set because I have like.
It's all set. I mean,
I have like
Aye.
4 finals.
this is set by Rico's office. You have like what?
4 finals.
4 finals on the same day?
Yes.
You can arrange it and you can negotiate if you want to move over the time and stuff. You know, if you choose me to kind of arrange you.
I'll probably not choose you, but some
If
other.
you don't choose me, I don't need to know.
Yeah.
If you choose me, I want to know as soon as possible. Any other question? Okay, so again, that's it. So today, let's start with Unit C2, Aerodynamics of Airfoils 2, okay? So again, those are essentially, you already know, first of all, pressure coefficient CP. So CP is important. You already plotted CP on your project, which is essentially the same thing, you know, if you try to plot the CP on airfoil, the big difference is leading edge here is x over c equal to 0. It's a leading edge. In your project 2A, 2B, leading edge is minus r. Okay? Minus 1, sorry. X over r, right? Your project 2A, 2B, x over r. So you plot it minus 1 to 1. Code ranks is 2. That's why 1/2 comes into play. So equation is slightly different. I think I explained it in handout or something. I hope. There's a difference between those project to be hints, right? This is just a hint. Okay. What about the other? Oh, it doesn't say. I used to have a difference. Where is it? I don't know. Kind of funny because I used to have a interesting sketch, the difference between circular cylinder and airfoil. Let's just draw it here. Okay, so the difference between the CP plot of what you did this is your CP plot, right? This is a CP, this is x over r. So you plotted CP from minus 1 to 1, leading edge to trailing edge. And of course, upper surface probably looks like this, lower surface probably looks like that, right? This is a CP for the project 2A, 2B, flow over circular cylinder. And then, of course, you did determine the area. This area is rift coefficient, right? That's what you did. So essentially, the very same principle applies here. So if you plot the CP distribution over upper and lower surface, okay, of a cross section of a wing called airfoil, of course, you actually normalize by code lengths. Now, big difference here is the code length is 2 times radius. So when you try to integrate from leading edge to trailing edge to determine CL, 1/2 comes into play for this case. Now this one's not, obviously. So that's the only difference. So CP plot here, plot at x over c 0, this is leading edge right here. This is 1, which is trailing edge. Okay. Then of course the same concept. Area bounded by upper and lower surface is essentially the coefficient CL. Now the reason why you're going to plot the CP in negative in positive upward direction is obviously upper surface. If you plot it, it's going to be a lower pressure surface. Lower pressure surface. And then here, the lower side is up higher pressure. Higher pressure, this side. Higher pressure, lower pressure. So this side is called pressure surface. This side is called suction surface. Because of the pressure difference, you're going to create the lift force in certain direction. It's called pressure difference. Okay. It's essentially the same thing. So that's why you want to plot CP this way. You can visualize which surface is a lower pressure, which surface is a higher pressure. Pressure difference is a lift. You can actually visualize it. This is lower pressure, this is higher pressure. Okay. So that's why everybody in aerodynamics plot CP this way. You can actually take a close look at a little bit more by looking at CP. Now, for X-5 special project team, you guys actually run X-5, and first thing to plot is CP distribution, right? And then CP distribution also at the same time, you can animate the pitch up and pitch down and see how the CP distribution changes. And also at the same time, you can visualize how the pressure is a force per unit area. You can actually visualize the pressure distribution on the surface as you pitch up, pitch down. You can visualize all of those things. I hope you bring that into the class and demo. Okay. And then, so you can take a close look at, starting from, let's say, leading edge right here. Leading edge right here starts, it looks like 1.0. What is the CP equal to 1.0?
Stagnation.
This is a stagnation point, and then you're going to trace over the upper surface. So upper surface pressure really, what's this? What's this? What's this kind of change? What kind of pressure gradient you are going to observe? Suppose if you have a CP1 really fast decreasing, go across the 0 point, go to negative and negative and negative and negative. Is it good or bad in terms of your lifestyle? Everywhere you go, pressure goes down. Is it good or bad?
It's really bad. It's like you're cycling between very high and very low pressure.
Very well, you know, as you try to move on the surface, starting from leading edge, pressure decreases rapidly. This is very favorable pressure gradient. That means, remember your first semester of your freshman, everywhere you go, pressure goes down and down and down. It's really easy to move on. And then you accelerate. Velocity goes up. Pressure goes down more. You are going to establish minimum pressure point right here. Okay? This is the minimum pressure point, upper surface. This is very rapidly favorable. Pressure gradient is negative. dP ds is negative value. This is minimum pressure point. Not always good, but it's usually good. Especially low speed, it's good. Okay. Now, all of a sudden, things change here. What semester your life kind of changes? Maybe right now, I don't know. When you start taking government classes. Okay. Oh my goodness. So you try to move on, and you try to move on, but pressure goes up, goes up, goes up, right? Goes up, goes up, goes up, goes up. Very advanced pressure gradient. Very advanced pressure gradient. And then if you run X-5, X-5 actually predicts you the transition. Transition happens around here. You know, the thickness of the boundary layer changes, and the CP distribution changes also. It's transition from laminar to turbulent. Because of the adverse pressure gradient, you have a difficult time. You have to transition from laminar to turbulent, trying to stick on the surface. However, oftentimes, depends on this contour, but if the contour is too adverse, you have to separate from the surface, okay? Temporarily reduce your pressure. But in this case, it looks like stay attached, okay, all the way to right here, trailing edge, another stagnation point, okay? Now, obviously, the area of the pressure negative, that means this is the area pressure negative, isn't it? Area of the pressure negative is this region. Okay, so this much surface is a lower pressure. How much lower? Lower than local atmospheric pressure. Lower pressure. Okay, so P is less than P infinity. So it's like a vacuum spot. Like a lower than local atmospheric pressure spot is formed up. Now, how about the other side here? Okay. The other side around here, close to leading edge, maybe around here, right? This is what? Higher pressure, right? Higher P. In other words, pressure is more than local atmospheric pressure. So you actually create a higher pressure zone around here, lower side, you create the lower pressure zone all the way here. As a result, net force, rift. Okay. So this is the mechanism of how the rift is created. Go ahead.
Is the shapes of the pressure distributions, is that also what gives wings their pitch up moment? Their pitch up tendencies?
So moment is essentially a tendency to rotate around certain location because of the distributed loading creates the resultant. Resultant multiplied by momentum creates pitching. So you can create leading edge, quarter chord, half chord, leading edge pitching moment, but it's going to be different values though.
Right.
But you can compute those things. So you're going to have a distributed pressure. It's going to create the resultant force. Resultant force multiplied by the momentum creates the moment. Okay. So that is essentially also comes with pitching moment. Pitching moment depends on location too. So usually quarter chord pitching moment is something we can measure in wind tunnel. Okay, so lots of things you can read off right from CP plot. So CP plot is usually the first thing to come when you try to design and analyze your cross section. So X-Square 5 is an awesome tool. You can visualize everything. CP keeps changing as you pitch up and pitch up and pitch up and pitch down and pitch down. It just keeps changing. And then as a result, resultant force acting on different locations. What is location, by the way? Center pressure. Center pressure. Okay, make a resultant is a center pressure. So if you take a location right here, pitching moment 0, that's center pressure. Right? Usually quarter chord aerodynamic center moment is constant. Do you remember those things?
Yes.
Okay, good. It's going to show up on final, okay? Guaranteed. So center pressure keeps changing, but at that location, moment 0. Okay. Anyways, so let's move on next page. So this is the demonstrated what you need to be doing in wind tunnel. Let's just take a look at picture here. Okay, wind tunnel picture. I have to pick it up like old. Okay, wind tunnel. So let's remember this. So this is a low-speed wind tunnel testing. It looks like you have tons of pilot tubes connected to the surface pressure taps. Okay. So what you're doing is you turn on, and then obviously the surface static pressure change happens. What's that? This is upper surface. This kind of. Have you seen that kind of distribution in the previous page? Yes. Right. If you connect up all the lower surface pressures, it's going to be, yeah. So you can read off the surface pressure distribution by using this kind of setup. So you can sort of determine pressure distribution just like that, depending on the angle of attack. It just keeps changing. And then next thing is pressure measured at the pressure taps determined to, well, convert it to CP. You have to. So let's just do a simple practice. This is the pressure distribution you measure using pressure tabs. Now this is going to be converted to CP, and then you just plot the CP distribution upper lower surface for each angle tab. And then integrating from leading edge to trailing edge gives you CL. In other words, area is a CL. Okay. So let's just take a look at practice here. Consider an airfoil. Airfoil model mounted in a subsonic wind tunnel. The test section airspeed is 70 miles per hour typical, and the condition is the standard sea level. This is wind tunnel testing. If the pressure measured at a point on airfoil, I don't know which point, I would guess, let's say 0.6 maybe. You just measured this point, pressure happened to be 2100 psf. What is the corresponding pressure coefficient at this point? Again, I'm just guessing here. You have to measure the pressure at every location of 20 static poles and then convert every location to the CP anyways. So let's just take a look at one of the points here. Okay. So let's begin with the test condition, standard sea level. So test condition, standard sea level density of air 0.0023769 slugs per cubic foot. Pressure 1 atm at standard sea level 14.7 psi, in which 2116.2 psf pound per feet square. Okay, standard sea level. And also I'm going to convert 70 miles per hour multiplied by 88 feet per second divided by 60 miles per hour. This is going to get you 102.667 feet per second. Okay?
That seems a little slow.
Yeah, 70 miles per hour. Yeah.
Okay.
Your car can probably run faster than this. Low speed window. So dynamic pressure is dynamic pressure of free stream is 1/2 rho v squared. Density 0.0023769 slugs per cubic foot. 102.667 feet per second square. So dynamic pressure is 12.527 psf, which is pound per feet square. Okay. So now you can determine Cp. Cp by definition, whatever the measured pressure P at this location, subtract P infinity, test condition free stream static pressure, divided by Q infinity. If you plug in, measured value is 2100 psf, standard sea level static pressure 2116.2 psf, divided by 12.527 psf. This is going to give you Cp minus 1.293. Minus means, okay, so this location is accelerated and less than the free stream static pressure. So that's why I'm choosing this point, because this point is accelerated, right? This is a favorable pressure gradient. That's where the incoming flow accelerates and then pressure drops. Go ahead.
But you don't know if this is on the favorable part or the unfavorable part.
You never know, so I'm just guessing it. So it's somewhere, probably upper surface where the velocity is accelerated, somewhere.
Okay.
So my guess is 6, 7, those points. We never know. But you have to convert every location, the measured pressure needs to be converted to Cp. This is the process. Go ahead.
If we were given a problem like this on an exam, maybe a final,
This is
I don't know.
this is like a joke. This is not an exam
I
problem.
don't know what you do.
This you don't need to study anything.
You can pick anything.
Well, this is just
You gave us derivations of the last exam, so I don't trust anything.
yeah. Derivation problems.
I don't have an
That's
issue with.
what you prefer. I can easily make one.
I don't have. I didn't say that.
I'm just kidding.
All I
I'm
said
just
is
kidding.
that I don't know what you do for
I'm
exams. We
kidding.
just pick stuff that we
No,
don't.
my exam is essentially almost all cut and pasted from whatever problem you did in homework or class. This
Fair
could be,
enough,
yeah, this
alright.
could be one of them. But this is probably seems too easy.
That's okay.
That's okay.
That's okay.
Yeah.
We don't have a problem.
Well, yeah. I'll think about it.
Right.
Well, you are better than that. I mean, anybody can solve that. I mean, you have to do this in winter anyways. So that's why I'm showing it, but you're better than this. Anybody can do this. Anyway, next page. So this is just a demo of how to convert, measure pressure needs to be converted to Cp, and then you plot Cp. Now, as you plot Cp, negative value, positive y direction. Those are very basic stuff of aero. So if you see people not doing those, point the finger and laugh at it. Definitely, because that is aerodynamics. Okay? It's quite important. People actually don't know those very basic stuff. is very lethal when you're trying to work as a team, starting from now. Okay, go ahead, question.
So CP negative
CP negative, yeah.
on the top.
Not necessarily. If you do this, you got CP negative here.
Okay.
Depends. But you know, if this is a zero angle of attack, it's probably around here maybe, because the shape allows you to accelerate. CP negative means pressure is lower.
Okay.
Okay. CP zero is pressure is equal to,
That's a cylinder.
well, CP zero equal to pressure is equal to static, free stream static. Okay. So I don't, sorry, pressure. So when you make a drill hole at the CP equals to zero, that's a static hole. Okay. All right, next page. So basically what you do is obtaining lift from CP distribution. This is something you already did on your project 2A2E. You are given CP distribution upper and lower surface as a data set. You can numerically integrate to determine this area, creating this tiny strip, another strip, another strip, another strip, another strip. That's going to be area. Is that something you did? Project to A to B. I hope so. What do you call that kind of method? Trapezoidal integration. Trapezoidal. The question is, if I give you a data set and ask you to, okay, numerically integrate, this is trapezoidal method, can you do it? Like a 5 data points upper lower surface, go ahead, finish up this table. I heard yes.
It's going to go on the exam, so yes.
Trapezoid MATLAB. Trapezoidal integration method. Actually, this is numerical. I'm not going to do that. Unless you see a similar homework. Did you see similar homework?
Yeah.
Oh, if so, yeah, too bad. Which one?
C2 to A.
C2 to A. Let's take a look. C2 to A. C2 to A. Ah, okay. Oh, yeah. Yeah, of course you can do this. Well, you already did it in your project. It's the same thing. Okay? Project, like I said, circular cylinder, data set is minus 1, 1. 1 part comes out. This one, there's 1. No 1 part comes out. So you can finish up this table. Actually, solutions given. What's going on here?
Well, you said this is an example solution.
This is examples. Oh, you're going to do the same thing in MATLAB. Yeah, that's easy.
But we won't have access to MATLAB for the final.
That's right. So that means, suppose if I erase out portion of this table and ask you to fill in, can you do it? Yes, you can. I mean, it's not like this much data point, maybe like a, I don't know, very coarse 5 data. Then I say, oh, here's the lower surface, upper surface data set given. Go ahead, find out, see if you can do it. It's all about this hint, right? Here you go. So this is it. Now that's what you're doing. Same thing. Instead of 1/2 integration from -1 to 1, you're going to do 0 to 1, no 1/2. The same equation. Okay. Yeah. Nothing to worry about. You know that. Okay. Yeah.
Is that because it's no longer a cylinder that we're getting rid of that 1/2? Or
Yeah.
no, it's because it's going. Sorry.
Yeah, -1 to 1. So this is 2.
Yes.
Close
because
to 2. That's
you're
adding
adding.
1/2.
Yeah. So if you get rid of that, then you would go from 0 to 1, and then you don't need the 1/2.
Yeah, in other words, you are normalizing with the 1/2 code. That's why.
Okay.
Yeah.
So
For
now we're just
actual
doing-
airfoil, this is x over c code length.
Right. So and now since we're doing it with dx, that's why it's okay.
Yeah, that's right.
Yeah.
Mhm. Okay. That's right. So the equation doesn't have 1/2 in it. Integration is from 0 to code ranks, or in terms of normalization, this is Robert, x over bar is this, okay?
Yeah.
Right? Okay, good. Well, of course you know. So for the circular cylinder, what is the equation? for the circular cylinder. This is 1/2 integral -1 to 1 CPL minus CPU dx over bar. Then x over bar is defined as x over radius. Okay, chord length is 2 times radius. That's what you did. This is the circular cylinder equation. You already know. This is the equation for airfoil. It's the same equation, it's the same thing. Okay. By the way, this is a quiz 7. Right?
Yeah.
Okay. You can do it. Sure. Quiz 7 is not a quiz anymore. It's a gift. 320 points. Right. Any question here? All right. So again, quiz 7. Take a look at the handout. Okay. Handout B3B, B34, B4B. Okay. Handout actually tells you all the details of mathematics. So this handout is a flow of a circular cylinder. If you apply the same mathematics to the flow of an airfoil, you can easily do quiz 7. Quiz 7 is essentially airfoil. B3B, B4B, those are flow of a circular cylinder. The only difference is obviously normalization based on radius, which is radius is half of the chord. Any question? This is the only difference, chord and radius. Right? Okay. So you can do it. So next page, let's take a look at class example problem C22. Consider an airfoil with chord length C and running distance x measured around the chord line. The leading edge is located x over c equal to 0. Like I said, x over c is equal to x over bar. Okay, normalized x. Trailing edge is equal to 1. Calculate the lift coefficient for this airfoil. The pressure coefficient variations over the upper and lower surface is given. So this is, how do you get these mass functions?
Piecewise?
This is a curved fit, isn't it? Yeah. So you have to understand there are distinctively 2 different types of integration of the data points. One is a numerical integration. Numerical integration really is trapezoidal. That is that one. Homework. Go ahead.
Is curve fit where you tell the computer, I think the equation will be some general form like this, best guess, give me your best guess as to what the constants are, kind of, or?
Yeah, well, several different kinds of curve fits. Of course, you have to specify polynomial, spline fit, exponential, linear.
Yeah, what kind of equation it will be.
Yeah, that's right. What kind of equation actually best fits the data set? That's the curve fit. So this is numerical integration. In other words, those are the lower surface, upper surface, CP, as given as a data set. You're going to use the data as is to determine the area bounded by those 2 data sets. This is called numerical integration method. This is something you did in project 2A, 2B. Okay. Now, here's the other one. This is my trapezoidal method. The other one is mathematical integration. This is more or less like a hand calculation. Okay, you can possibly do this hand calc. So here's the situation. You are going to actually plot. Okay, CP. And let's say, well, this is upper surface CP data set given I don't know how many data sets given. This is the lower surface data set. Okay. So what you're going to do, you're going to do a curve fit. So first of all, upper surface curve fit. And then upper surface curve fit in this range. So two different range of upper surface need to be two different function to curve fit. So this is CPU range-wise 0 to, let's say 0.1, okay? This is the CPU in the range 0.1 to 1. Okay. Lower surface happen to be just a single equation to curve fit. CP rho is 1 minus 0.95 x over c. This is the entire range. So happen to be upper surface need to be two functions to curve fit. This could happen. So that is the situation here. So this is the mathematical functions given based on the curve fit of data. So under such situation, how can you go ahead and mathematically integrate by using hand math? So you are going to do this, okay? CL is equal to 1 over C integral 0 to C CP lower minus CP upper dx. In normalized coordinate, this is essentially integral from 0 to 1 CP lower minus CP upper dx over C. Let's see. X over C is oftentimes called x over bar. Normalized coordinate. So mathematically speaking, you are going to actually represent CP upper with two functions, CP lower in single function. So this is integral from 0 to 1 lower surface, 1 minus 0.95 x over c dx over c. Okay, this is lower surface. And then minus integral from 0 to 0.1, 1 minus 300 x over c square dx over c minus integral 0.1 to 1 minus 2.2277 plus 2.2777 x over c dx over c, in which do you write hand math? So this is x over c evaluated from 0 to 1 minus 0.47. Sorry. Okay, so this is x over c evaluated 0 to 1 minus 0.475 x over c to the square evaluated 0 to 1 minus x over c evaluated 0 to 0.1 plus 100 x over c to the cube evaluated 0 to 0.1 plus 2.227. Do you like this? X over c evaluated 0.1 to 1 minus 1.1388 x over c to the square 0.1 to 1. If you do all the hand mathematics, it's 1.4. This is CL. Then I go like,
All right, now do it again.
I'm not the mathematician. Why do I have to do this kind of reaction? So how would you do this? in reality as an engineer. Go ahead. Yeah.
Couldn't you plug it into MATLAB and just let MATLAB suffer?
Oh, MATLAB, you say. Let's take a look. MATLAB, you say. So here's a handout of C2. This is the same solution here. MATLAB live script. Okay. So here we go. So this is CP upper surface function 1, function 1, function 2. Two functions to represent upper surface here, here, here. And then lower surface is a single function. Here we go. And then this is the CL is integrate CP lower from 0 to 1 minus integral CP upper function 1, integral from 0 to 0.1 minus integral CP upper function 2, 0.1 to 1. That's it. 1.40. Well, at the very end, you're going to actually combine it. I guess you guys do it. Dynamics or something. It's a piece of cake compared against dynamics. There's nothing. Go ahead.
In the example problem that we just did, we are given functions for CPL and CPU.
Yeah.
In the homework problem, C22, I believe it is, are we given those functions?
Well, which one? C21.
C22, I believe, the
C2.
one that we went over where you need MATLAB for.
This thing, right?
Yes.
This thing is a numerical integration. In other words, you're going to data and numerically integrate. Now, this one, suppose if you plot this CP on Excel, let's say, okay, then if you curve fit and squeeze out the function, you can do the mathematical integration by hand. So you have two different methods to do. So in this case, this is a numerical integration. You basically go ahead and do that. But suppose if you want me to create such a program, let's say I'm going to use Excel to curve fit, express this and that, maybe two functions for upper, one function for lower. Functions given, go ahead, finish up your integral by hand. You still probably. Network's dead. Hold on. Something went wrong. Trying to get you back into the meeting. Hold on. Connecting. Well, yeah, it's okay. Well, no, it's online anyways. But recording may be disrupted. So this is the numerical integration. So things I showed you in here is a mathematical integration. So this is like a classic method. You don't have access to MATLAB. You do everything by hand. But anyways, at the very end, you pick up MATLAB anyways for to do symbolic math. So two different. One is numerical. One is mathematical integration.
Okay, so on, say, a final, since we obviously won't have access to MATLAB or Excel, it would be something similar to this rather than the homework problem.
If you want me to create this kind of thing.
Please don't. Please don't. No, I was just
We really
speaking.
don't.
I was speaking purely hypothetically.
When we ask you a question, it's not we want you to do this.
Yeah, my
just
overall
wanna know.
yeah, my overall impression is okay. This is Aero, which is engineering class, not mathematics class. So I'm not interested in a program which requires heavy use of math anyways, because that's all of a sudden test of math, not the aerodynamics. But I would probably heavily emphasize what is concept of what you're doing, kind of thing. That's something I like to test on find more. Question, go ahead.
Yeah, so what's that number next to x over c cubed?
Huh? Sorry?
X over c cubed, what's the number next to it?
X over c cubed. 0 to 0.1. What?
No, on the left of it, the last. The coefficient. It's
It's
100.
100 times x over c cubed is what the question was.
180?
Oh,
No, 180. It's
It should be
180.
180. Yeah, it should just 300 divided by 3.
100 is.
1.8? 0.475. Yeah, this is 100. Sorry. 100. Sorry. So this is 100 x over c cubed evaluated from 0 to 0.1. That's what it is. Although I'm not interested because I will use MATLAB anyways.
I don't.
Okay? I'm very less interested in those details. I'm not a mathematician. I never do this kind of math anyways. Nowadays. I use TypeScript and smart math. So let's stop here today. So next class, we are going to pick up high speed of 2D airfoil aerodynamics, which is critical Mach number. This is actually quite important. MCR, critical Mach number. This is actually one of the design factors for airplane, which actually is high speed. Okay. Critical Mach number. And then drag divergence, and then supersonic speed. We are going to cover a little bit of high end. Okay. Any questions? Yeah, go ahead. Yeah.
Will we get our project 2 ready for in project 2B?
Okay.
Will we be able to like see our grade or see what we did wrong for project 2A before we submit?
Yeah, I try.
Okay.
Yeah, I try to grade it immediately.
Okay.
I do try. Yeah. Anything else?
Yeah, it's good. It's good. It's
All right. See you guys back on Wednesday.
we're trying to get it back to 180.
Yes, we are. Yes, we are.